All right, folks, Chapter 2, homework problem number 19, and here goes. A cement block accidentally falls from rest from the ledge of a 53-meter high building. When the block is 14 meters above the ground, a man 2 meters tall looks up and notices that the block is directly above him. How much time at the most does he have to get out of the way? Now, this is a complicated problem. Lots of different things going on, so let's draw a really, really good picture. The building itself is 53 meters high, so we have 53 meters from the top to the bottom of the building. We have a man who is 2 meters tall. Here's our little person. I'll give him a hat because I like people with hats. I think hats are cool. And he's 2 meters tall from top to bottom. And when the block is 14 meters above the ground, he notices that the block is directly above him. So 14 meters above the ground, 14 meters above the ground, or I'm going to put this in another color, 12 meters above the man. He notices that there is a block. There is this block that is going to come down and whop him on the head. We want to know how much time at the most does he have to get out of the way. Okay, this is going to be a multiple part problem. First off, we're going to have to look at the motion of the block from the instant it fell off of the roof down to the point where the man notices. So let's call this part 1, from the roof to the notice. Okay, till the man actually notices what's going on. What do we know about the block? Well, it had an original velocity of 0. How far did it fall? Well, how far did it fall? Well, it was 53 above the ground and 14 above the ground when he notices. So 53 meters minus 14 meters is how far it actually fell. So let's take a look at that. 53 minus 14, it fell an entire distance of 39 meters, and we're carrying everything out to 3 sig figs. It is accelerated downward by gravity at 9.8 meters per second squared. We really don't care about the time it took for it to fall this far, but we do care about its final velocity. If we want to calculate how much time it's going to take for this man to get out of the way, we have to have an idea of how fast this block is going at this moment. So let's find the final velocity of the block right here where the man actually notices. So what equation has VO, VF, A, and X in it? I think I would choose VF squared is VO squared plus 2AX. Original velocity goes to 0. Final velocity is going to be the square root of 2AX. Let's put our values in there. So the final velocity at the point where the man notices what's going on is 2 times acceleration of gravity, 9.8 meters per second squared. It has fallen a distance of 39 meters. And again, in my calculator, I have 2 times 9.8 times 39 equals, and then square root all of that, and I end up with a final velocity of 27.6, if we carry it to 3 sig figs, meters per second. So that's the velocity when the man notices what's going on. Okay, now we're going to care about this section right in here. What's actually going to happen while the fellow is noticing? So let's take a look at what we've got here. For that section, we know that the block has an original velocity of 27.6 meters per second. We know it is going to travel a distance of 12 meters before it hits the man. Where did I get that 12 meters? Well, it's 14 meters above the ground, 2 meters to the top of his head, maximum 12 meters above the man, that he has that much distance to get the hay out of the way. So It has 12 meters to travel. Gravity is still accelerating it at 9.8 meters per second squared, and we're looking for time. Time is going to be my question mark. Now, if you look at this little beastie, you might be tempted to use x. Oh, goodness, what happened to my screen? There we go. You might be tempted to use x is VOT plus 1/2 AT squared. If you do that, you're going to end up with a t here and a t there, and you have to use the quadratic equation. If you are very fond of the quadratic equation, go forth and use it, and you will do a fabulous job. But if you're not fond of the quadratic equation, here's a workaround. And the workaround is we're going to do it in another step. And that is we're going to find the final velocity after it has traveled an additional 12 meters. After it has traveled that additional 12 meters, once we have that number, we can then find time. So I'm going to find VF. So to find VF, and I don't have t, but I have a and x and VO, I'm going to use VF squared is VO squared plus 2ax. I'm going to solve for VF by taking the square root of both sides. So final velocity is going to be the square root of my original velocity for this 12-meter section, 27.6 meters per second quantity squared, plus 2 times 9.8 meters per second times the 12 meters. It's going to fall. When I do that, what am I going to get? Okay, calculator time. 27.6 squared gives me, and let's do this in sections in case you get lost, 762 meters squared per second squared plus 2 times 9.8, whoops, 2 times 9.8, there you go, times 12. So this is plus 235 meters squared per second squared, plus that's 762, and we're going to square root all of that, and we end up with a V final of 31.6 meters per second. Now I'm going to put a bubble around it. It's not my final answer, but it's an important answer. And now I can go back with all this lovely information and I can find time. What am I going to use to find time with all this? I'm going to go back to VF equals VO plus AT. Time is going to be equal to final minus original divided by A. And that's going to give me final velocity was 31.6 meters per second. Original velocity at the beginning of this segment was 27.6 meters per second. Gravity is accelerating at 9.8 meters per second squared. So what have I got here? Let's see. 31.6 minus 27.6 divided by 9.8. And we end up with time is 0.408 seconds is the amount of time that the man has to get out of the way and make sure he does not get schmucked by the brick. Alrighty, folks, that will do, and we will see you next time. Bye-bye.